got internet this time. Good. Okay. Here I am on our cluster in one of the workers, host name, CO19, Scratch, ls. So these are the files that I asked you to take off, to remove. Okay, so this is, if you're wondering, ls-la. So we know who writes these files, users 40, 48, 53. The only ones that should be there are the transaction.csv, transaction.zip. You can experiment with not unzipping it, and that's fine. I left it there for you. Everything else needs to go away. Make sense? And since I asked you nicely last time, this is your second warning. I'm going to take off points in homework 4 if you don't. So this is a shared space. You know, it's kind of like going into a lab and leaving your stuff all over the lab. This is not what we do. We clean up after ourselves, and I'm just showing you that. So with the cluster, we've used some of lots of resources, and that's fine. But for the homework, when you're on our stat class partition, what happened last time is that when I looked at the job queue at 2 hours before the homework deadline, there was like 20 people in the job queue. And they won't be able to have their stuff run if you ask for too much resources. So with that, let's limit it to 2 CPUs per task if you're running on our partition. If you're not running on our partition, then you can use whatever resources you want. Okay. Questions on this? Yeah? How do you write into, or how do you clean up? So what I've logged into it now. So I am logged into this worker node, so I can write to a file right now, like echo hello into test.txt. So that just created a file called test.txt. If I'm just working as if this was my home directory, it's not my home directory. It's a shared space, the Scratch partition, on one of the nodes in our compute cluster.
So you moved into the worker node?
Yeah, so I logged into the worker node, which is fine. But if I look at pwd print my working directory, it's /scratch. So slash is on our local machine. I'm in Scratch. If I go to my home directory, and that's just cd with no arguments, print working directory, home Clark F. Here, I have all my personal things. Your personal things belong inside your home directory. /scratch on the worker nodes is a shared space. We all have to use it. So therefore, I don't want you to put all your intermediate files inside there. So when you make this table of contingency counts, put it in your home directory, please. Not there. Questions? Make sense? Okay. All right, let's at least make sure we get the bootstrap. Oh, really? Yeah, that's all right. Fix it later. Okay, and I covered all this stuff. Here we go. Thanks. But before I do that, I should let you ask questions. Any general questions about the homework usage? Yeah, David?
If you're typing the unzip file to your program,
yeah.
like for Python, what is the how would you read the data into like CSV?
How would you read the data into CSV?
Yeah, like I'm thinking about like pandas, and I read CS or read CSV.
Uh-huh.
But what if I'm typing in there? What is the parameter that you put in?
So you're reading standard in. So the answer is to read standard in. So in Python, that's as I showed you. Let me find that example. I think I have it. Slash. Find it. By the way, feel free to, this is the examples directory of the course notes. You can use any of these you want. I mean, even copying it directly, it doesn't bother me. The challenge in this assignment is putting it all together, and you'll have to probably make some modifications to make all these work. Yeah. So that's one possible solution. You could create an intermediate file. The other thing is to do this standard in. If pandas can read standard in from its CSV reader, then that should work okay.
So it's read CSV and SVDIM.
Yeah, where you import from sys. But I'm not sure if pandas can do that. Do people know? Have people tried this? The question was, can pandas read from standard in? I suspect that it has a way. I'm just not sure if this is the way.
I mean, if it can't, you can unzip the file and then just like.
Yeah, you can unzip it or select the columns that you want and save those to an intermediate file and go like that. That sort of thing will work too. Becomes a regular file? Yeah, it's a readable connection. Yeah.
Also, would you mind like I do one step in Bash and then the other step in Python?
In Python? No, I think that's totally cool. I think you should definitely do that. or multiple different languages. Yeah.
And to execute your Python script, you would just do that shebang line with Python and then just paste on.
Yeah, let me show you because we're getting these questions on it. Just do it. I think I have it open here. So here's an example of how you could do that sort of thing. And these are all saved inside the lecture notes. So what I'm doing is I'm using bash commands and Python commands and R commands all at the same time in one pipeline. That's what's going on here. So in the same way that in Python you can loop through standard in, just process a line at a time using very little memory, you can do the same thing inside R. And that's what's going on in this line. So this line, I'm just sliding in rather than bash commands that consume standard input and produce standard output. They're Python and R programs that consume standard input, produce standard output. And that gives me a lot of power and composability. So I encourage you to play around with these ideas for this homework. I think you can do some cool stuff. Of course, you can always make the intermediate files but this is kind of elegant, and here's the reason why. I'll just show you. So I'm running all these lines here. We see this, my prompt in bash has not yet returned. I should mention this right-hand pane here. This is me on C019, which is one of the worker nodes on the cluster. So I'm unzipping this, piping it to all these commands, and saving the result to test.txt. Exactly the same thing like we were doing in the previous assignment. So here I am also logged in to this same host, but I want to see what's actually happening. That just needs to be smaller. All right, cool. We can actually see it now. But does it? Okay. All right. So let me. One of the other things that I wanted to show you today was some performance measuring tools. So I'm on this worker node, and I call top. Top shows me what is happening on this computer, on this server, at some given time. On my Mac, I was doing it with the activity monitor, but from the shell, I can use that web interface, that Ganglia, to look in and see what the total load is, or I can use an old school tool like top. So top is what we're checking out here. So interpreting this means that user S141C31 is running an R job. The command is R, so he's running an R job, and I shouldn't say I don't know who this is. And it's consuming 80% of the memory on this node. So how much memory is available? I think 64 gigs, I want to say. So they're using like 40 gigabytes of memory. In contrast, this pipeline I just wrote, where all these users are ClarkF, this was me. Actually, it's still running, I haven't killed it. These commands are unzip, cut, Python 3, and even my top that's running. All these are not using any memory at all, essentially. 0, 0, 0.1, 0. This is characteristic of a streaming program. This is how you really want your streaming programs to behave. To use almost no memory at all. They just move through the data, or the data passes through this pipeline of processing people, and they gather up everything that they need. When you use 80% of the memory, it means you're somehow reading everything in and trying to do it all at once. And you're approaching the limits of memory that we saw earlier in this class. Your performance will just completely tank. And fun part on a shared resources is that the performance of everyone else's programs will also tank. So we need to figure out how to rewrite this to use less memory. This percent CPU, so you can see so this is using a full CPU, 99%. My program is using 93%, so close to a full one on R. Unzip is using 70%. Python is using 23%, cut is using 70%. And I think that's all I have in my pipeline. So from this, you can figure out what the actual bottleneck is in my program. it's the one with the percent that's close to 100, and that would be this R process. So that means when I go to improve the performance of my pipeline, I should look at the R script first, see how I can make that one go a little bit faster. It also shows me that I won't get any benefit by not unzipping the data ahead of time, because unzipping is not the bottleneck here. Unzipping is only using 70% of the CPU. Still, if I'm using 2 cores, I might get some benefit from unzipping it. Okay, any questions on this top output? Yeah. Thanks, Jen.
401 total is like one stop, 0 is only. What does that mean? Like under second line?
Under the second line, tasks?
Yeah.
Yeah, so this is a snapshot of how the computer is running at some given time. And I don't know what all of these mean, but 400, that means there's 415 processes running on this machine at one given time. Top sorts by the CPU usage, but you can sort it by different things. And there's also age top, so you're mostly just interested in the processes that you are running. But in case someone else is using a huge amount of memory, you need to figure that out too. Yeah.
Like we find out someone else is having a task and using big memory and seems like it's already around for a really long time. Can other user help them cancel it?
No. No, you cannot. Unless you're the systems administrator and you have to have permission to kill other people's jobs, which is, of course the way it has to be. But I can kill their jobs because I have their login credentials, right? So I can just log in, and if someone starts something and then goes on vacation for the next 2 weeks and uses our whole partition, I can delete that, or the TA or the reader. So hopefully we are aware of these things and we don't run into this problem. But I have the hunch that it will be a problem, so I'll show you how to actually go check this. Because I showed you how to use srun to get into here, right? So I use this srun command. I hesitate to show you this. If I show you this, don't abuse it, okay? Do what I say with this one. Huh?
What is the difference between using the I flag and not using it? The I flag? Or if even... Right.
Oh, bash dash I. So then it will just try to run bash, but not interactive, so I think it won't do anything. So what this is doing, this is the srun, this is the thing I showed you. You can use this is totally fine. The thing that I do not want you to abuse, but it'll let you see the output from top, you can log in directly to this node. So I'm logged into Gauss inside here, my host name. I can move from the head node to a worker node without using srun. SSH Clark F at, what was the one, C0-19? Okay. So this subverts the whole queuing system. It goes around and underneath it and lets me log in. But the reason I might want to do this is so I can run top. And this is the only reason you should use this. So repeat after me. The only reason you should use this is to use...
Why was the problem with using this?
What's the problem with using it is people are requesting resources, and if you log in directly and use the worker nodes directly, then they might not get those resources because you're using them. So you kind of damage the whole queuing model if you were to go over here and run some really expensive commands. But top is not expensive. Okay. So I just run top and I can see this output. And it's the same thing, that it's just a lot better formatted because I have a smaller screen, I guess. So we see my commands still using a bunch of CPU, no memory, and this one that's hogging all the memory here. So you should be thinking about this when you're building your pipelines and your programs to how can I avoid this. All right. And then when you're done, exit, get out of there. That's that. So it was chaining SSHs, right? SSH from one machine to another to another. Any questions? I had all this stuff to do, but I didn't really get to do it. So we'll do it next time. I do want to show you how to count things, because I haven't done that yet. Just look at the plan here. So do the bootstrap, counting. Oops. So here's some data. You might sort your stuff and have data that looks like this. From the shell, you can count it with just this unique -c, or I think sort also has a flag for this. So built-in ways to count your data. Just plug them into a pipeline. If you want to use R, then if you read all the data in at once, so this is where you could get into trouble if you read the table and the table is exceedingly large. That's where you can use a ton of memory. Then your counts are like this. So this is how you build this contingency table of counts inside R. It's just the table command function. So you could also kind of mix it up, and you could take the output of unique into read.table inside R. That's what I do here. Counts. So here, when I did that unique.c, it gave me this, and this just split it on white space, and I have strings. It's the string a, 1. So I would have to go in here and massage it and get it to be the numeric count table that I want it to be. So that's just string processing in R. Not a big deal. Python, while we're at it, also has an easy and actually very elegant way to do this. And that's counter. Module load Python 3. I'm still on the cluster, I think. No, I'm on my local machine. Forget. Okay. So this is what we did before, an iterable in Python. I read all the rows in my data file and convert them to tuples. It's a generator expression. Any iterable you can pass to a counter, a collections.counter in Python, and you can count what you have. Okay? And this will stream through the data and count up all the times it sees something and make a contingency table for you. You'll have to massage it a bit to get it to be the right form, but that is that. Okay, I'll see you Thursday.
as like from the obligation, and I did the string split. So all the strings were like this. And then I tried to do the passive lock.
Just hang on a second. Let me stop recording.
Can I take a picture of the previous terminal, the task manager?
The top?
The terminal.
The SSH here? This?
Yeah.
Yeah, go ahead.
Thank you.